Next class, you should know how to define a limiting reactant and percentage yield. A limiting reactant is a reactant that is completely consumed during a reaction and limit the amount of products formed. Percentage yield is the ratio of actual yield divided by theoretical yield. Okay, as in a lecture, you already know that actual yield will be given in question, whereas theoretical yield must be calculated from stoichiometry. So now we're gonna learn how to calculate a equation involving limiting reactant. So first, please check. So first of all, please check whether the equation is balanced or not. Okay. So first of all, anything that you want to do in chemistry, please check whether your reaction is balanced or not, or else you are gonna got the whole thing wrong. Okay. So how you gonna know which equation asking for limiting reactant? If you write a question that providing both info on reactant, okay, so you have to find the limiting reactant first. Okay, because for example, in question 1, if NH3 is the limiting reactant, or my short form LR, then when limiting reactant is already used up, these products, nitrogen, copper, and water, will not be formed. So that's why it is really important for us to find the limiting reactant first. Let's start with question 4. So check whether the equation is balanced. Okay, so N, we've got 1 N at the reactant and 2 N at the product. So you need to multiply the NH3 by 3. Okay, so now the hydrogen is 6. So you need to multiply H2O by 3. So the oxygen in here is 3. Meanwhile, this is 1. So you need to multiply the CuO by 3. And 2. So this copper solid. Okay, in here we have 3 copper. So this Cu solid need to multiply by 3 as well. So let's take out all the information given. So if 28.5 gram of ammonia, so this ammonia weight 28.5 gram are combined with 145 gram of copper oxide, determine the following. Okay, first the question will ask you to determine the limiting reactant, the mass of each product, which we have 3 products in here, and the mass of excess reactant. So step 1, find the mole provided. Okay. So mole provided must be calculated using information given. Okay, I repeat again, mole provided must be calculated using the information given. So mole NH3 would be 28.5 gram divided by the molar mass 14 plus 3 gram per mole. So that would be 1.6765 mole. Okay, again class, remember your mole should be in 4 decimal places. Okay, find your mole CuO pro. This pro means provided, okay? This is not professional or anything else. So the mole for copper oxide is 145 gram divided by 63.6 plus 16. So you've got 1.8216 mole. Step 2. Draw two beakers. Okay, and label them. The first beaker must be labeled as provided. And the second beaker must be labeled as mole needed. Okay, so add in here mole provided. Right. So fill in your information of mole provided that you have calculated in step 1. But first, write down the respective reactants in the balance equation. Okay, so NH3 and CuO. NH3, the first reactant is NH3 and the second reactant is CuO, and the same one must be written in this beaker of mole needed as well. Okay, so fill in your beaker of mole provided. So mole NH3 would be 1.6765 mole, and this would be 1.8216 mole. Okay, so after you draw the beakers, write the respective stoichiometry of reactants next to the provided beaker. Okay, so focus on your provided beaker because you need to fill in this mole provided beaker first. Okay, so what is the stoichiometry for NH3? Yes, that would be 2. So write 2 next to it. So what is the mole for CuO or stoichiometry of CuO? That would be 3. Okay, so write 3 next to your CuO. Okay, what I need you to do now is to do a cross multiplication to find your mole needed. Hence, moving on to step 3. Step 3, find the mole needed. Okay, so we need to fill in this beaker of mole needed using cross multiplication. Okay, so what I need you to do is to what is it called? Is to erase this information. Okay, for example, I want to find about NH3. Okay, so close your NH3 mole. Okay, because we want to find it. We don't know about it, so we want to find it. So what's left is you need to times or divided the number. Okay, so the number left is 2 times 2 times 1.8216, okay, divided by 3. Okay, so you've got 1.2144 mole. So for this step, if you are confused, then just write a short note. Okay, if your number is on the same side, then you have to divide it. If your number is on the opposite side, then you have to multiply it. Okay, for example, this 1.8216 and 2 is in opposite position, so you need to times it. Okay, so this 1.8216 is in the same side, so we need to divide it. But it's gonna be okay, guys. This is just a simple cross multiplication. I hope you won't get confused over it. Okay, So find your mole of CuO needed. Okay, oops. Okay, so now I'm gonna hide my mole of CuO because I want to find it. Okay, if you want to find something, that means you don't know about it, right? Okay, so what numbers are you left with? So what is this number? 1.6765. So 1.6765 times 3 divided by 2. So you've got 2.5148 mole. Okay. So now you need to fill in your beaker of mole needed. Okay, so your mole needed of NH3 would be 1.2144 mole. Write the unit as well. And the mole of CuO would be 2.5148 mole. Okay, so we already fill in both beakers. Okay, right now what I want you guys to do is to subtract the number of mole provided minus the mole needed. Okay, and if you've got a positive sign, then it means that it is an excess reactant. And if you've got a negative value, then it means that that is your limiting reactant. Okay, so let's see. So 1.67 minus 1.21. Okay, so you've got, so I just want the sign, not the number. Okay, so 1.67 minus 1.2. Well, obviously you've got 0.2 something, so there would be a positive sign. So means NH3 is your excess reactant. Okay, what about 1.8216 minus 2.5148? Well, obviously you will be getting a negative answer. So that would be, this means CuO is your limiting reactant. So move on to step 4. Okay, you have to do a ratio. Label the limiting reactant with star. So we already determined that the limiting reactant is CuO. Okay, so put a big star on it and the beaker opposite it. Okay, so this CuO is the opposite of this NH3. Okay. So right now I need you to write your ratio. Okay, from equation. So from this equation, 2 mole NH3 is equivalent to 3 mole CuO. Okay, so write down that equation. So 2 mole NH3 is equivalent to 3 mole CuO. Okay, so the reason why I ask you to star these numbers is because I want you to write it down for the calculated ratio. Okay, so for mole NH3, So mole NH3, which one that you've already put a star on it? That would be this number, right? So write down this number at here, 1.6765. Okay, and your mole CuO, what is the mole that you've already put a star on it? This number. So that would be 2.5148 mole CuO. Okay, class, the reason why I'm asking you to put a star on it is because I don't want you to calculate this ratio again, because you will be getting the same answer all over again. And please be smart, do not waste time in your calculation. Okay, so if you're wondering why I'm doing that star, let me show you. Okay, so for example, you need to find the mole of CuO. Okay, so you'll do the cross multiplication, right? Okay, so hence 1.6765 times 3 divided by 2. You'll be getting the answer as 2.5148, right? So you already find it in your beaker. Okay, so don't waste your time. Okay, be smart, work smart, and get a 4 flat. So step 5, determine the limit rate. And for this, you have to write a sentence. This is, so you need to write this in PSPM as well. Okay, this is compulsory. So mole CuO provided is less than the mole CuO needed. Okay, so let's check. Okay, the mole CuO provided is less than the mole CuO needed. Yes. Hence, these 3 dots means hence. You can use it in PSPM. Hence, CuO is the limiting reactant. So we are done with finding limiting reactant. So next, question B. Find the mass of each product. Okay, so now you have found your limiting reactant, put a star on it, which is your CuO. Now, what you need to do is to compare all the products to CuO. Okay. For example, I want to find the mass of N2 first. Okay. So for N2, 1 mole of N2 is equivalent to 1 mole N2 is equivalent to 3 mole of CuO. Okay, refer to your balance equation, 3 mole of CuO. Okay. So you've got to find the mole of N2 first before you find the mass of it. Okay, so for 3 mole of CuO, you need to use the mole provided. Okay, you need to use the amount of mole CuO provided, which is 1.8216, because this is the maximum mole that I can give to you in order to form your products. Okay, remember class, always use mole provided of limiting reactant. So 1.8216 mole CuO is equivalent to 0.6072 mole of N2. Okay, so now you've got the mole of N2. Can you find the mass? Yes. So the mass would be mole times molar mass. Yes, 0.6072 mole times the molar mass, 14 times 2 gram per mole. So that would be 17.00 gram. Okay. For Cu, okay, so the balance, so the stoichiometry of mole of Cu is 3. So 3 mole of Cu, again compare it with your limiting reactant. So equivalent to 3 mole of CO. So 1.8216 mole CuO will form 1.8216 mole Cu. So now find the mass of Cu. 1.8216 gram times 63.6 gram per mole. So you've got 115.85 gram. Okay, the last product is water. For water, compare it with 3 mole of CuO as well, with the same mole of limiting reactant. Okay, so you've got the mass of water 1.8216 mole times 18 gram per mole. So that would be 32.79 gram. Question C asks for mass of excess reactant. So what is your excess reactant? Oops. So that would be your NH3. Okay, so look back at your beakers. Okay, so you have to minus the mole provided to the mole needed of NH3. Okay, and the balance would be your excess. So there would be mole provided is 1.6765 minus 1.2144. Okay, so your excess mole is 0.4621 mole. Okay, in order to find mass of unreacted NH3, you have to times the excess mole or your unreacted mole with molar mass. Okay, so your excess mole or unreacted mole would be 0.4621 mole times the molar mass of NH3 is 17 gram per mole. Your final answer would be 7.86 gram. So let's take a look on how you're gonna get all 10 marks. Okay, question for limiting reactant contribute at least 10 marks in PSPM. Okay, so let's check together. So the first thing is to find your, first mark would be given for your balance equation, second mark for your mole NH3 and mole CuO provided, third mark is when you fill in this mole needed beaker. 1, 2, 3, 4. Fifth mark is when you write this ratio, and then your determination of limiting reactant in the form of words. Okay, and then next to find your mass of each products, And lastly would be to find your mass of unreacted NH3 and your mole of excess reactant. Okay, so all these limiting reactant question contribute 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so maximum mark is 10 marks. Okay, so be careful that you don't miss out any steps. Okay, next question 6. Okay, for question 6, you are given, okay, again, two information of mass on both reactants. Okay, by direction of both reactant is by double replacement. So this information, double replacement, means nothing. Okay, it's just some words in the question. Okay, so check whether your equation is balanced or not. So 2H3, 6 hydrogen, and this 6 hydrogen. Okay, so this equation is already balanced. Okay, so off you go. Please complete all the question of 6 and question 5 and 6 by yourself. Okay, just follow all the steps that I gave to you.